Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will do the high frequency analysis of field effect transistor amplifier. As far as high frequency analysis is concerned, we have to take care about the stray capacitance. Let's see how to work with stray capacitances and how to do high frequency analysis with that. Let us consider FET amplifier circuit with self-bias or voltage divider bias. Both can be possible. So this is N-channel JFET, and we have to investigate the high frequency analysis. That means you have to decide up to which particular high cutoff frequency we have to work the FET as an amplifier as far as this circuit is concerned. So let's first of all let's see that how these three capacitances work at low frequency and high frequency, and then we will jump towards the another type of capacitor that is called as internal capacitors. So CC1, CC2 and CS. At low frequency, that means if F tending towards 0, I'm not saying exactly equal to 0, but it is tending towards 0, so I can make a statement that XC is tending towards infinity. Now infinity means that it's nothing but open circuit as far as circuit is concerned. So it should be open circuit for your low frequency analysis. And what about the high frequency analysis? At high frequency, we have to say that F is tending towards infinity, XC is tending towards 0, and that should be short circuit. So this CC1, CC2 and CS will not play the role of high frequency analysis parameters, and that is why we require another type of capacitors which are nothing but the stray capacitance. Let's see how these stray capacitances work at high frequency and low frequency, and whether they are responsible at high frequency and low frequency or both. First of all, you should get to know that what that stray capacitances is. First of all, this FET is an active device. Whenever it gets fabricated, there are layers one over the other, which forms few capacitances in between two terminals. This is gate terminal, this is drain, and this is source. Each two terminals form the capacitors in between. This two terminal gate and drain form one capacitance, that is CGD. This gate and source form one capacitor, that is CGS. Drain and source is again forming one capacitor, that is CDS. Now we like to look at high frequency and low frequency analysis, whether these capacitances are really responsible to design as an amplifier. Now at low frequency, F tending to 0, XC tending to infinity. So actually this CD, DS, GS and GD, all these capacitances are become open circuit. So we can say this is open circuit, and that's what we want for the amplification circuit, right? So for low frequency we don't need to design all these capacitances, rather low frequency cutoff के लिए I don't need any parameter such as CGD, CGS and CDS का value for the designing. Now let's look at high frequency analysis. For high frequency analysis, as f tending to infinity, this xc tending to 0. Now what will happen if xcgd, cds and cgs becomes 0? Then drain is connected to source internally, gate is connected to source internally, and gate is connected to drain as well internally. That means this is chaos, completely khichdi of all the terminals, right? And in this way very high amount of current will flow in the circulating manner of ds and g. This will not work as an amplifier. This will not work as an amplifier if they get short circuited. But I want to prevent them to be short circuited. I want them to be as valid value of xc, which is even though it is high value. So what we will do? We will do the designing of cutoff frequency, because frequency is nothing but 1 upon 2 pi RC. We all know that what's the value of C while fabricating. This all C values are in picofarad. Picofarad means 10 to the power minus 12 farad, which is very less valued. Now we have to design the value of R in such a way that I will reach to particular value of FH, right? This is your design perspective of the circuit. Now in this video we are learning analysis perspective. That means we have to calculate the value of FH for given circuit in which R is given and C is given. So we'll first calculate what's the value of R for particular RC circuit at input and output side, particular value of C for input and output side, and then we will formulate what should be the cutoff frequency at the input and output side, and then we will choose one of these cutoff frequencies. Now we are on the actual track of high frequency analysis. Till now we have studied that why we have to do high frequency analysis, what that stray capacitances and how they are playing the role in high frequency analysis. First of all, I know that responsible capacitors are CGS, CGD and CDS. So very first I will draw the circuit of FET amplifier again. I will try to convert it in AC analysis equivalent model such that things will become simple. I will short circuit all the capacitors because we are doing high frequency analysis. At high frequency, your XC will become 0 and that will act as a short circuit. So here as well, I will be getting short circuit of CC2, short circuit of CC1. This is input. Here I will be getting output, and RS is become redundant in this case. I will also show these three capacitances which I have to take for the analysis of high frequency. Namakaran will be CGD, CDS and CGS. Try to go for AC equivalent model. As far as FET is concerned, FET का AC equivalent model is input is with open circuit VGS, output is connected to current source which is dependent on input supply voltage, that is VGS, dynamic output resistance, here I can say it's a drain, this is gate and this is source. RS is redundant, so this source is directly connected to ground. I will place this as ground terminal. Input is connected with parallel combination of R1 and R2. I will treat this as RG, and here we will be getting the value of Vi. Similarly, at the output side, we are having only one resistance till now, that is RD. If load resistance is available, I will place RD in parallel with load resistance. Now important part is left, how to place these capacitances. Similar to terminal, gate and drain के बीच में I will be getting CGD. In between gate and drain I will be getting CGD. In between gate and source I will get CGS, and in between drain and source I will be getting CDS. More than that, few capacitances which are formed by connection with the metal at the connecting terminals. So that is called as input wiring capacitance and output wiring capacitance at the input and output side respectively. So I will write CWI as input wiring capacitance and CWO as output wiring capacitance. That we have to include, nothing else. We will form this circuit separately at the input side and output side. This is combined form, so we'll try to separate it out and we'll find out, we'll judge that whether it is possible to form RC circuit and whether it is possible to form the frequency formula with 1/2 pi RC. At the input side, gate resistance, this is RG. Capacitances, this is first CGS in between gate and source. Another is wiring capacitance, that is CWI. Now you get wonder that what about the capacitance which is placed at input as well as output side, that means CGD, that means CGD. CGD is connected in between input and output, but don't worry, we have Miller's theorem which will simplify our circuit, which is replacing this CGD at input as well as output side with the function of gain. So we'll treat this CGD as Miller's input capacitance, and now here your gate terminal, here your source terminal which is connected with ground terminal. This is your input. This will form your input side of FET. I can determine that F is equal to 1/2 pi RC, where R is equal to RG. Directly I will be getting because open circuit in the model of JFET. C is equal to, this is parallel combination of CGS, CWI and CMI. Okay, I will write this CMI as 1 minus multiplied by CGD. So I'll write it over here, parallel combination, that means addition, CGS plus CWI plus CMI. This will give you first cutoff frequency, that is with respect to the input side of FET amplifier. Then we will investigate the circuit which is at the output side. At output side we have one current source which is GM into VGS. Here we do have one resistance, that is small rd. Again one resistance which is again in parallel with small rd, that is capital RD. Capacitor, that is CSD or CDS, you can say, in both way it is correct. Wiring capacitors at the output side, that is CWO, and Miller's output capacitance. This is how your circuit is. VO, this is connected with ground. I can also determine directly FH2 is equal to 1 upon 2 pi RC. We have to determine the value of R and C. R is nothing but small rd in parallel with capital RD, and C is nothing but addition of CSD plus CWO plus CMO, whereas the value of CMO is equal to 1 minus AV into CGD. So this is how we have learned so far about input and output side of high frequency analysis part. But now there is a question. We have got two cutoff frequencies, out of which one I have to select as particular cutoff frequency above which my circuit will not permanently work as an amplifier. So that is threshold frequency we'll have to decide. Question arises, on what basis I have to decide? So understand the frequency response. This is the frequency response curve at high frequency side. This curve you will be getting, and if we say that first frequency I am getting over here, that is FH1, and second frequency I am getting over here, that is FH2. Which frequency I have to select? Point A or point B? Your answer should be point A. This is because after point A your gain is attenuating. So if you select FH2, then just above B you are getting attenuated gain. You are not getting the gain which is nearly at the high value of gain in between mid frequency response. So that is why your value of FH should be minimum of FH1 comma FH2. So this should be your final answer. If we take an example, FH1 is equal to 100 kilohertz and FH2 you are getting as 2 megahertz, then I have to select least value, minimum value out of these two values. So FH is equal to minimum of FH1 comma FH2, and that is equal to 100 kilohertz. That should be your answer, right? So this is how we have done how to do the analysis of high frequency in FET amplifier. As far as numerical is concerned, we will take one or two numerical based on FET as well as BJT. So stay tuned for that videos, and learn more and more EDC along with me, along with Ekeeda videos. Thank you so much. Do subscribe Ekeeda channel.